What's inside the SpaceX Starship? Elon Musk is a man on a mission, quite apart from his tricky day job weaning mankind off gas-guzzling automobiles. He also plans to drag our civilization over to Mars, and he wants to do it soon. To this end, Musk has been frantically developing a pioneering interplanetary vessel known as a Starship, launching and iterating fresh prototypes at a frankly insane rate. But how does it all work? And what's inside that giant shiny cylinder that keeps crashing? Today, we gingerly venture onto the long-suffering Boca Chica launch pad for a sneak peek inside the Starship. During a recent interview with podcast host Joe Rogan, Elon Musk offered a typically smirking, juicing glimpse into the thought processes behind his signature rocket. Musk told Rogan he'd watched screwball Sacha Baron Cohen's comedy The Dictator, in which a tin-pot leader of a fictional nation orders his engineers to make a rocket point here in order to strike fear into the hearts of his enemies. And actually, that's also what I said, the same thing. Musk told Rogan, Starship, we need to make it more pointy, he apparently informed his SpaceX team. Rogan asked Musk, quite reasonably, if a pointy rocket is significantly more aerodynamic than a blank one. Musk replied that the new design is arguably slightly worse. Still, everyone thought it would be funny if we made the rocket more pointy. So we did. Not only is Elon Musk's great hope for the future of mankind pointy, in the grand tradition of classic sci-fi rockets, but his 164-foot-high Starship is also notably shiny. Why? Because it's made of stainless steel. This is for a number of reasons, as Musk himself has helpfully explained elsewhere. It's obviously cheap, and it's obviously fast, he told Popular Mechanics. And fast in terms of production fits nicely with his vision of getting to Mars in the swiftest possible time. Expense is another factor. Carbon fiber, a more conventional rocket building material, costs some $135 per kilogram, but around a third of carbon fiber ordered from the manufacturer needs to be scrapped when wastage is taken into account after being cut to the precise size and shape needed to make a spaceship. So the true cost of carbon fiber is actually nearly $200 per kilogram, explained business whiz kid Elon Musk. Compare that to just $3 for stainless steel. Stainless steel also has a high melting point and obvious advantage in rockets. Carbon fiber can only tolerate a steady-state operating temperature of around 300 degrees Fahrenheit, whereas steel can comfortably get up and even beyond 1,500 degrees Fahrenheit without undue stress. This is thanks in large part to its shiny, mirror-like thermal reflectivity. And when you consider SpaceX his choice of fuel, cold liquid oxygen and methane, stainless steel offers the additional benefit of not turning brittle at ultra-low temperatures. Ever the tinkerer, Musk has looked into superior forms of stainless steel for use for his Starship prototypes. The present alloy used, known as 301 stainless steel, certainly has a good pedigree and has seen action in spades for decades. But as he tweeted last year, we should be able to do better in the 2020s than we did in like the 50s. So I think we'll start switching away from 301. Maybe in the next month or two, he goes on healthily. To be rather more specific, some parts will use 304 as it has higher toughness at cryotemps. 301 stainless steel alloy comprises a blend of nickel, chromium, and iron and is more resistant to corrosion. 3 or 4 is similar with a higher chromium content, which makes it slightly less likely to corrode and slightly higher performing when it comes to bearing heavy loads at high temperatures. The rings you see running up the side of Starship prototypes every 1.8 meters are an artifact of the fact it's constructed using stainless steel, 1.8 meters being the standard maximum roll height of commercial steel. So what's inside the steel tube? Up on top in the nose cone, we find the payload compartment on current prototypes. This is left more or less empty, but in time it will be fitted out into a multi-function in the cargo bay. Alternatively, depending on the application, and certainly only after they've got the hang of landing crew quarters, here could hold about 100 people comfortably on a trip to Mars. However, that number could be increased, thinks Musk. You could conceivably have 5 or 6 people per cabin if you really wanted to crowd people in, he recently mused, but I think mostly we would expect to see 2 or 3 people per cabin, and so nominally about 100 people per flight to Mars. This payload bay will also host common area storage space and a shelter where folks could hide out in lines chambers from potentially cancer-causing freak solar storms. Right now, phone footage taken by Musk himself up in the nose cone shows a spherical device known as a head attack. More on the fuel situation shortly. But while we're up here, it's worth pointing out that Tesla battery packs attached to car engines adapted from a design used in Tesla's production Model 3. What are they doing up here? The overarching design philosophy of Starship puts a premium on reusability, which means ultimately this giant steel beast has to land at some point. But unlike its much leaner SpaceX Falcon cousin, which lands vertically almost as a matter of course nowadays, the Starship is so huge it needs to do something altogether more ingenious to bring stuff. Shipped most of the way to the ground flaps are extended from the side of the rocket. The idea is these use Earth's atmosphere to slow the descent. As Musk puts it, you're trying to create drag rather than lift. It's really the opposite of an aircraft. This approach to lounging, or at least getting close enough that Starship engines need less fuel for the last leg, requires much less fuel and hence weight than the Falcon method. The Tesla batteries and engines up top operate the actuators that extend the flaps. Clever stuff! Further down the rocket, we come first to the liquid oxygen tank, then to the liquid methane tank. This fuel mixture, unconventional compared to more traditional rocket fuels, was chosen by SpaceX for several reasons. On balance, it's less dense and therefore less weighty than using hydrogen. It burns clean, which is crucial when you're hoping to reuse rocket engines time and time again. Also, thanks to the discovery of ice on Mars, future missions can apply a bit of chemical was a dream known as the subhardy, a process to generate mythos fuel to spur on the homeward journey in situ on the red planet itself. These 2 giant tanks contain a whopping 1,200 tons of fuel separated by a near-hemispherical bulkhead known as the Common Dome. This bulkhead is in itself a great SpaceX innovation. Conventionally, oxygen and fuel tanks are separated by 2 hemispherical domes, wasting precious space in the gaps between the back to that sphere in the nose cone, which is one of the 2 header tanks on board, the other sitting in the common dome we just mentioned at the interface of the oxygen and methane tanks. The nose cone had a tank hole to separate the supply of liquid oxygen, and the common dome had a tank containing its own stash of liquid methane. These reserves are only brought online during the final stage of landing once the main fuel supplies in the big tanks have been exhausted. In this way, Starship's thirsty Raptor engines can enjoy fresh, high-pressure matrox when they most need it. Thanks for watching the video. If you enjoyed it, please like, share, and subscribe to our channel for more such exciting content.